Okay, continuing on in our slow manner. I'm going to step into this function now, finally. This shouldn't do anything. Now let's hope that that's what happens. Okay. So push AX is the first thing we expected to see. The other video is actually uploading while I'm doing this. I mean, if you saw the previous one. Now 80 is the command line position. Increment, so that now sets AX to be pointing at 81, which is our command line. So not including the count part. And remember, it's null terminated. And now I'm calling the slash DQ to carriage return, which I have total confidence in now. Alright. Now the question is, how long before it quits? It should quit on this one, which is searching for a slash, and our command line has no slash, so this thing should return a null. So first we're saving off BX, because we're going to use it, and moving AX into it. That was what was passed to us. This function is not using any calling convention, just a fast call, meaning registers only. Now into BX went AX, which is a pointer. We prefer to have pointers in BX. Now into AX, the slash character, and we're pushing the slash, and we're pushing the pointer, so it's stir-cur. As a prototype, character pointer first and count second. So in reverse order, count, then pointer, and let's see, the first thing we pushed was not count. This should say car, ch. It's an integer type, but it's actually a character value. Because you can't push a 8-bit value on the stack. Okay. And 181 will be stir car, but we've seen that before, so I'm just going to proceed, and this AX should come back as null, which it did. Clean up the stack. Now we check if it's null, jump it to 0, so here we are, to done. So done should simply pop BX and return. Unassemble. Just going to see if we can see it here from here. Here it is. 838, that's correct. So that's where we're jumping if the 0 flag is set, and it is set. So this should take us there. And then we are at 838. Pop BX, whatever it was when we came in here, and return. Now we're on another pop, which is this one. We're done with getting rid of slash double quotes. There weren't any. And now go back, up, not there. Just put that one. There's a lot of comments in here. Now we're on this bit. Now what we're doing here is recalculating the length of the command line, because it's possible, as I said, that if there was a slash quote, that this length might have changed. Now this function could have returned a flag telling us that, but unfortunately I didn't do that, so it's going to have to go through this calculation every time. It's going to push 81, call Sterling, and then just set the value without checking if there's any change, because it doesn't save any time to check if it changed. 81, push 81, call Sterling, which should return 36. There it is, 36. Clean up stack, move into bx80, and now we're saving 36 over top of our 36. Alright. Now, next step. Now this is a big long description here. Removing all quotation characters, as well as replacing some spaces with A's based on an even-odd boundary condition. Concatenate the modified substrings, then replace these with 22, so it's double quotes, and then that is the string we're going to send into the parsing routine. And there's one thing missing that has to be done before sending it to the parsing routine. Replace these with 22s. Re-terminate. Well, maybe it's not necessary, but I think it's done anyway. It should be done. Command line with B, because the normal command line that is expected to be carriage return terminated. Boy, I love this knowing what D is. Sorry for this. We should find a way to automate this process. Okay. Yeah, we null terminated it, but we should turn it back into determination, because that's the normal expected command line. I don't recall, but I think it does use that D actually. Yeah, we'll see. Now, so the next bit is to call this do replacements. Well, first let's just call into it. And that should be not too far away. Here it is. Now this one uses a list. This is that list that we copied over from the home world, from the real world. I thought that this would be a long list of things that I needed to replace, so that's why I decided to use a table. The first 2 bytes of being a count. Could have used 1 byte, but whatever. And then the next, this is a count of word values. and each word value has a thing to search for and a thing to replace it with. So this, and it goes backwards. It replaces this one with this one. So it'll replace a double quote with a 0, and then it'll go to the next replacement, and it's going to replace a D with a double quote. You see? So that has the effect of getting rid of all the real double quotes that actually do something, and then restoring the D's back to their double quotes that they should have been. And at the end of that, what's going to happen is these characters, we haven't had any D's, but these quote characters are all going to be zeros. Okay? And I believe that it also might be replacing this with a D, but we'll see. These are 22s. Okay, well, let's just see what happens. Here we are. First step is to retrieve the first word value from this list, which should give a 2. And in fact, it says 2. That came from the home world. Now we're checking to see if there's nothing to do. If not 0, which it isn't, go to 848, otherwise return. Same old story. I'm always using these little jumps because, again, I don't need to put in a label, and the compile time doesn't go insane. Okay, trace over that, and now we're putting into BX the car replacement pointer. So that one was a read of a value, the first word value from that pointer, and now we're just going to take the pointer value and use BX to step through it. And we'll add 2, get over the first word, and now we're going to read into DX the word value from BX, which is 22.0, and see, it reads better once you put it in a register. It converts high to low. So anytime it finds one of these, it replaces it with one of those. Now AX into AX goes the command line, call 861. So obviously this do replace function knows about the format of this string. That is, that the first byte is a count. Otherwise it would have incremented AX by 1. Okay, so let's see, do replace. There it is. Into there. Push B and C. Into BX goes AX. Now this one's going to use BX to walk through the same list and move into C low, which is going to be a counter 36, the length of the command line. And being careful, zeroing out C high. That's good. I'm happy to see that I was careful. That means that we are not there. here, run this line, this line, and checking if the value of the entire register is 0. Now, I suppose I could have just checked C low against itself. I don't know why. I decided to do it this way for some reason. If 0, untrue, go to 876, so that's not going to happen. That must be this leave. Bump up bx to point to the actual data. Again, I'll actually have that in here somewhere. Here's the actual command line. It hasn't been modified yet in any way. And now, compare so it's searching for 22s. So I'm not using any built-in function. This has got its own simple comparison logic. If it's not a D high, 22, which it wasn't, go to 874. That's this. Jump over move. Okay, so all this is this simple loop. Whenever it finds 20, a D high, 22 in this case, it won't jump, and it'll replace that value with D low. So in this case, it's not 22, so we jump over and we loop to 86D, which simply increments dx, and repeat. Now I can just proceed. I'll try and get to one where it's not too far away. 20 is 54 is a capital letter. That must be a capital T. Oh yeah, because we haven't been through the parser yet. Okay, H is this 73 space I must be S 20. It's coming up. Not this one, but okay, this one. The next one's going to be a 22. Okay. Now, this is going to be the true condition. So it falls through, and now it's going to replace dx, position 8f, with d low 0. Now let's dump 80, and sure enough, that quote is gone. So copy this over. Kind of pointless because I'm going to proceed to the what I want to do is this. But I didn't really need to do that because I'm going to push P right now and let it walk through the entire thing and then dump it again. Okay, so now at this point in the replacement sequence, this has been modified. And let's see, one here has been gone, this one is gone, so here's one, and here, okay, so that so far is what's been modified, one, and this one of course. Okay, now we are done the do replace loop, and we should be popping CX, which we are, and return. Now we're on another loop. Oh, that's right. Remember, this inner loop is part of another outer loop, which is walking through the list of search replacements. So we've done the first one, CX, whoops, yeah. We're going to loop here, and CX is going to go down to 1. This other table, if you recall, had only 2 elements in it, 22 and the D22. So now this one, we add BX2, we move into the search replace word value, a new replacement, again, put AX back to 80, and call that same function, which I'm going to proceed through, because, well, it actually doesn't matter, because it's not going to find any. 36, we get the sign, check, seen this before, go to the command line, and here we're looking for D's, and there won't be any D's because we didn't find any slash quotes. So I'm going to proceed when we get to the loop, and just to double check, this should be the same with no additional changes. Okay? Return. Now this loop is finished. Return. That brings us back to, so we're done these replacements. The next bit is this alternating concat. Now the idea here is to trace through this string and basically do a string cat, stir cat, you know, the runtime, C runtime stir cat, which takes strings, calculates the length, and concatenates one string on the other. But in this case, on every second concatenation, it's going to replace spaces with A's, which are line feeds. So I'll trace to the top of that, find it in here, alternating concat. Concatenate and alternating strings in place, alternately replacing 20s with A's. And restoring the D. Yeah, see, that was what I was wondering about before, where that gets restored. And it has to be restored for the tokenizer. Now, this uses first is a bunch of pushes, then zeroing out the 80 into SI. Now, it's going to just compute again the position where the D should go by taking that 36 value, adding SI, which is 80, to adding 36 to 80 plus 1. There's a 1 beyond the length is where the terminator goes. Trace. So now we have our D back. I don't know if I'm going to bother with these brackets anymore. Too much work. And there's going to be a great big change here on this one. So, well, if I'm going to put brackets, I might as well wait till this is done. We are now here. We just replaced the D. Now into SI goes BX. I don't know why. It was already equal to that value. It may not have been necessary. Move 80 into SI, below SI. Yeah, I don't. Oh, BX might have changed. Did it change? Yeah, it was 36, so it's been restored back to 80. Okay. And now into DX goes. This is another thing where I'm using a single register for holding two values. Now the idea here is kind of silly, but it works. You'll see in a second. I'll get down to the function. Okay, now there's a loop here from here to here. First, we move into AL, the value at BX, checking if it's 0. So we're looking for null termination here, or 20. Now see what I've done here is instead of keeping track of where we are, all I've done is whenever I see a space, okay, it gets replaced with whatever's in DL, even if that happens to be 20. And then I swap the D high and D low and just keep doing this replacement. So I never have to compare, which are we in an even or odd region. It's the same logic every time. We replace all 20s with D low all the time. In this case, it just has no effect. We'll see through the next loop. Okay, so that won't have done anything. As you can see, we still got those 20s, but now we gotta concatenate. We gotta concatenate from this spot, I suppose. Copy down in place. So it should be, it's the same copy down as before. Just taking the count, which is in CX28, because we moved ahead several bytes. AX is nothing at the moment. Let's just step through a couple of these first. Checking to see if there's nothing to do. Into AX goes the count. Increment. So we're pushing one more. Again, just like before, the count that we want to copy is always one more because we want to include the terminator. And incrementing bx, which is 8f. It's 8f. Oh, 8f is our position in here. That's here, 8f. No, 8f is where the null is. And that's going to be the source. No, the source dest. Yeah, dest is the last thing in the first thing in the. Hang on a sec. Decrement and then push. Yeah. Okay. I haven't incremented bx yet. So see, bx is 90. That's this 66. And now that is going to be the source. Now bring it down again. Push that. That's the destination. So we're copying down from everything, including the 0, the whole command line, into this spot. So this should become a 66. We'll proceed with that. And so it is. But now the length of the command line is changed. So that has to be recalculated or just decremented by 1. Whoops. Let's make sure that we have that there. Clean up stack. 0 out. Okay, now this is one of those things that I don't know if you know this, but if you want to swap two things and you don't want to use any extra registers, 8b4, 8b4. You do this 3 XORs, and the 3 XORs will swap the two values. Like if you wanted to swap AX and VX, you would do XOR AX VX, and then VX AX, and then AX VX, and that will swap the two registers. That's a way to do a swap without having to use a temporary variable. Now it's kind of cute the way it works, and it's very easy to prove why this is true. But I'm going to leave that as a puzzle for you. You see? They're swapped. Started with this and ended with this. I'll give you a hint. Well, maybe I shouldn't give you this hint. It's a giveaway hint. I won't give you the hint. It's easy to prove. That's my hint. There's nothing to it. Now I'm going to decrement whatever's at SI, which is 80, this position, by 1. So this will become 35. Which it is. Copy this over. Okay, so now, what's happening is the count value of the command line is going down, and that's a good thing. And recall, back in the land of where nobody knows what's going on, everything is exactly the same. Nothing's changed. Unlike the debug program, which made a mess of our command line, we're not making any mess. We're not altering anything in here. Okay. Down goes bx by 1, then loop. Now I don't know if I need to loop through that again. Okay, we'll do one more iteration just to show you how dumb this thing is, and what's great about it is how dumb it actually is, because you know it's not doing any thinking. It always does exactly the same thing every single time. Whenever it finds a space, it replaces it with d-low. That's all it does. It doesn't even, know that there's a swapping going on. It thinks this could be used to replace all characters with d-low if you want. But also you can maybe, I'm not going to find any spaces in there. Oh yeah, there's one. Yeah, we should find one. Not going to get there quickly. 8-9E. Here, so that's at position 9A. 9. That's this one. Okay, I thought we did that one. So there is one anyway, and that's going to become a d-low, an A. There it is. Okay, so now I'm just going to proceed from here on. Call to 10. Where am I? 8AE. I guess that thing, no, it's not done yet. It's going to, loop, return. Who called this? And alt concat looping call to 10. Oh, this is a mem copy, I think. Yeah. Oh, darn it. Yeah, I think that's the mem copy. Yeah, it definitely was. The next loop, let's flip again back to 20, but I'm going to proceed over the loop and then dump out the result. The command line now is down to 33 characters, so we lost 3. Yeah. Copy that. 33, yeah. So our final result had 3 replacements. Here they are. Here's one, here's one, here's one. And there was a concatenation. So all of the quotation, that we would have knocked out 3 quotation marks. And here they are. 1, 2, 3, and that's why the length went down by 3. Okay. Let's stop doing that. Pop, 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 return, more popping, pop, 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 and return. Now we're returning from the big function. And where are we now? We have just done the search replacement We've done the alternating concatenating, and we're returning, and now this thing, this thing here is now ready to be passed on to the regular old parser, 710. Now we're back, way back. That's different file in fact. I have it. Let me help you. No, yes, I can have it. Now we're done the pre-parse, and it's going to go on to the regular old parse that we've already seen. Here's our new command line, and after the parse is done, all those A's are going to remain, and all the 20s are going to disappear. And in the storage area, which is at 440, I think, will go the parsed strings. Okay, so I'm just going to proceed through this. I think it's at 440. Oh no, 440 is the pointers to strings. It might be 400 maybe. No. 3FE maybe. Well, one way to find out. The argv store, the pointers are 440, and the argv store is at 240. The 23E plus 2. Well, actually, why don't I do 23E so we can see the count as well. So the count is 5, and these are the null terminations. We should see the A's still in there. Here's one. Yeah, that's one of them. So here's a string that has an A in it. So that means that this string is going to include that ending quote. All of them are null terminated. 1, 2, 3, and then all the way up to here, 4, and 5. So it's done. Now the only thing left to do is to replace those A's back to spaces, which is what they started out as. And that's what this function does. Originally, this function did a lot more. And I found out that not only did it not need to be doing those things, but it was incorrect the way it was as it stood. So I actually just went in the debugger and hand-coded the search replace on the fly and just pasted it in here. Where are we? The post parse. Here it is. Yeah, I just, it was wrong, and it's just a simple single character search replace, and in just like 5 minutes I went through and did it in debug and pressed write and pasted it into a file, and then injected it in here and deleted everything that was already there. So all this is a single character replacement, nothing particularly interesting. So there's some pushing, a lot of it unnecessary, getting the count of strings, and now I'm going through this list of 5 strings, which is 5 is not 0, so we're not jumping out. And putting into first thing I guess is it's storing the pointer, retrieving the pointer. I see. Instead of figuring it out by searching for zeros, it trusts the parser. The parser tells us where the strings are located. So there are 5 of them. So we load into dx the value from SI, 240. And then this here is just a simple search replace. And see how far down does it go. I'd like to advance to this line, following the loop. This is where we're going to go back into that twilight zone and copy the new data back to the homeland. So let me just proceed to where's the loop again? 97A. And dump 240. Okay. So now you see that those A's are lost. I should have copied the other one. Those A's have turned into spaces. The strings are still as they were. The parsing is complete. And the only thing left to do now is to open up that little gap between our universes and copy everything back down. So the first thing we need to do is align ES, because it's ESDI, no double D's, with CS, so that's been done. And the first move is the table that includes all of this stuff. Currently in CS line, 23E is empty, and the other one is 440. Also empty. We need to fill it up with our result. So we put into CX the count 302. The 2 is meant to include the count by word. That's our intersegment data transfer, which I proceed, and now I will dump CS 23E, which now has our result in it. And next is jumping to done. I guess that's no. What about the pointer? Did we miss that part? Oh, there they are. Oh, that includes the pointers as well. That's certainly less than 300 away. Okay, so that included everything. We don't need to restore we don't want to restore the PSP because there's no need to. The parser has done its job. And the fact that it needed to have that thing modified to do its job is of no importance to anybody else, even us. We'd rather leave it as what it was. Now, I think we are where are we? I don't need this anymore. Not in my file. Should be in CA here. We should have just completed the advanced parts. and the cleanup. And we should be calling main soon. Unless we, oh, I see. This is part of the addition. I'm pushing the argv and argc on the stack before calling main, because this code is going to be taken out of this file and it won't be available. Okay, push that, and calling 1,000, we're in main. So that's it. That's the entire parse. Everything is completed. Our PSP is completely unaltered. The information, the RVs are set. The string pointers are all fine. There are no weirdo characters. Quotes are gone. Everything nicely spaced out. I go, and here's the printout. Okay. Next time, if you want, I'll put in some slashes or something so we can see that happen, but in a much quicker way. Alright, see you then.